Hello and welcome back to this series of short videos on the SCA. I'm Claude Bellil, now retired, but former manager of the SCA product line at Viavi Solutions. In the previous session, we introduced the SCA as a component-based development and deployment architecture for complex software-defined systems. We mentioned that the SCA-based applications can be built by connecting already made components, just like we would design and assemble a digital hardware board. The components are provided as black boxes with capabilities, input, output, and control ports. So in this video, we will see how, using this design paradigm, we can quickly build an application. To make it simple, the applications we will be developing will produce a low-frequency sine wave or an audible tone. We will modulate it in frequency and then demodulate it to play the tone on the computer speaker. We will show by analyzing the signal constellation that the sine wave has really been frequency modulated. Pretty simple, but it will quickly show the main concept for the development of applications as an assembly of components. For this, we will make use of Echo Architect, an SCA modeling tool offered by Viavi Solutions. With the tools, we will drag and drop on the canvas already developed components and will connect them together to create the data flow. We will then use Echo Inspector to install the SCA applications on the computer, start it, configure it, and inspect the signal trace within the applications in between the components to verify the FM modulation. So let's move to Echo Architect, the Viavi design and modeling tools for SCA applications. In this demo, we will not cover all the features of Echo Architect. That would be much too long. We will only show what is needed to execute our task. In a following video, we will dive a bit deeper and show more advanced features for auto-generations of SCA code. So here's a screenshot of Echo Architect. On the right side, we have the canvas where the application will be developed. On the left, in the fridge, we have a repository of components and applications that have been developed for other projects. In this example, we will use already made components to create an application. In the future video, we will show how to create components from scratch. But for now, let's keep it simple. So we will create an application that produces a sine tone, modulated in frequency FM modulation, and then demodulate it to get the original signal back and play it again on the speaker. We should hear a tone. So let's start. In a project that we called Sine Wave Test Project, we will create new applications that we'll name FM Sine Tone. So let's pick from the Echo Toolbox library, another tool offered by the Viavi Echo Suites, the components that we'll need. The sine wave generators, that will be the first one that we will put on the canvas. We will upsample the output of the generator to get a smoother modulation. Then the FM modulator. At this point, we would normally place the transceiver to go over the air, or we could place a channel emulator, but let's keep it simple and we'll go directly to the demodulator and decimator. Now we have on the canvas all the components with their signal processing that we will need for the application. Give me a second now to quickly realign the components on the ports so we can go to the next step and make the connections between them. Let's now make the data flow connections between the components, linking the output of a component to the input of the next one. Remember, all of those components are in essence black boxes with input, output, and control ports. Let's beautify the connections a little bit. To control all of those signal processing components, we will need an application controller. I had it done prior to this demo, so I'll simply drag it on the canvas. Let me again reorganize the component layout a bit and then we'll make the connections between the controller and the control ports of the signal processing components. Okay, now we have all the signal processing components and the application controller connected. We now need to connect the application to the audio device or the platform speaker. For this, we'll drag again from another project an audio device emulating the speaker of my computer. This is the beauty of the SCA, the reuse of components from previous projects. Then we make the connections for the data flow and the control. Now we have everything we need. The signal processing components around, the system controller in the middle connected to all the control ports, and the audio device representing the computer speaker. Let's now install this newly created application on the computer processor and run it to hear the tone. In Architect, we right-click on the applications and select Run on Local, meaning running on the local computer. We could have asked it to run the applications on an external platform, but for here, we make it simple. From Architect, the suite now switches to Inspector View, the Viavi SCA tools for platform monitoring and introspections. You can now see that all components have been installed and are ready. The red dot on each one of them indicates that they are in the stop mode. So let's start them. We now hear a 500 Hz tone as shown in the parameters window at the bottom left. Let's change it to 1000 Hz. And let's quickly bring it back to 500 Hz. And then turn the speaker down so we can continue the demonstration. Another interesting feature of the Echo Inspector tool is its capability to plot data coming out of the components. This is possible because the SCA is a component-based environment. So let's plot the output of the FM modulator to see that the tone is truly FM modulated. Let's plot the constellation view, which for FM should be a circle of 1. And here it is. We can now stop the demo and uninstall the application. In the next video, we will continue to dive a bit deeper in the SCA. We will see how it works, what are the main constituents of the core framework that is responsible for the life cycle of the applications. We will touch on the main responsibilities of the application developers and platform developers. So, see you soon.